Okay, I just realized that we hadn't finished notes, so I'm going to put notes up real fast with the buffers. So buffers basically are a solution that resists change of pH. They're usually a weak acid and it's salt, or a weak base and it's salt. But a buffer helps us maintain a specific pH. A buffer capacity is the amount that it can resist change. So if I put too much acid in, a buffer will break, and that's past its buffer capacity. So a buffer can only buffer for so much acid or so much base added in. So a buffer is a solution whose pH changes very little. Most buffers are solutions composed of a weak acid and its conjugate base, or a weak base and its conjugate acid. We already talked about that on the last slide. So without a buffer, if we add the same amount of acid, you can see the pH goes from 7 to 1.7, or if we add a specific amount of base, it goes up to 12.3. But with a buffer, we can keep it really maintained about the same 4.7. That's important because when we eat really acidic things or we eat really basic things, we don't want our body to all of a sudden swing to very acid or very base, because then it would kill our cells. So we've got to have buffers, and we actually have 3 buffers in our blood. So a general characteristic is if I add an acid, it will, the excess acid will react with a conjugate base, and overall the pH doesn't change. Okay, the ratio here does not change. It doesn't go back or forth. Well, it does go back and forth, but it doesn't affect it very much, the ratio. If it's a base, same kind of thing. We add a base, it takes and reacts with the acid, and we get water, and we get a base that's not as strong. So it doesn't affect as much. So when we have a buffer, we worry about the Ka, we worry about conjugate base, we worry about conjugate or weak acid, what is it? And then we're worried about what's happening side to side. So in our system, we've got several buffers. We've got intercellular fluid and extracellular fluid, and you can sort of follow it down here. And with those buffer systems, we're able to maintain a specific pH, which is very, very important. Okay, so when we calculate, whoops, sorry, went a little crazy there. When we calculate the pH of a buffer, we use the equation Ka. So we just basically do Ka. And we get down to this equation, and that's good, but it actually gets a little better when we use, I think I've got Henderson-Hasselbalch in here. Henderson-Hasselbalch takes the log of both sides. And so if you take the log of H3O plus, you get pH. If you take the log of Ka, you get pKa. If you take the log of a number here, it flips it so the base is on top and the acid's on the bottom, and you just log it. Okay, so if we focus on the human body, one of our very important buffers is the carbonic acid bicarbonate buffer, because we're constantly breathing in and out CO2, and we need to get it out of our blood and make sure our blood doesn't become too acidic. So for respiratory acidosis, that results when the body fails to eliminate CO2. People hold the breath, and we end up having some problems. So they have them blow in a bag and do things like that. For respiratory alkalosis, this is when we're hyperventilating. This is more the bag thing. Sorry, the other one wasn't the bag. We just need to have them breathe deeply on the other one. This one right here, they breathe it into a bag. They're actually bringing more carbon dioxide back, so we re-establish that buffer pH. So this is the Henderson-Hasselbalch I was trying to tell you earlier. This is going to be a very important equation. You're going to want to write it down. You're going to want to have it close to you, because she'll give you the Ka, she'll give you the concentration of base and concentration of acid, and ask for the pH. Well, if you've got this equation, real easy, plug in. Okay, just remember pKa is just the negative log of Ka, just like pH is the negative log of the concentration of hydronium. So we've got some examples here, and I don't have set up so that I can write it down, so I'm just going to talk it through to you. So here we have this equation, like I told you would have earlier. You've got the acid concentration, the base concentration, and 6.5, and you've got the Ka. So the first thing you would do is take the negative log of Ka. That will give you pKa. and you're going to use Henderson-Hasselbalch's equation, remember this one? So you do the negative log of the Ka to get pKa, and then you go plus the log of the base, which is 6.5, divided by the acid, 3.0, and you'll get an answer. Okay, same thing here. You can practice it out. Again, go back to this equation right here. And remember that pKa right here is just negative log of the Ka. Anytime you p in something, is negative log. All right, again, another one that you could practice. So let's go forward here. Calculate the pH of the following buffers. Again, same thing. Okay, I've given you a lot of examples, a lot of things that you can try. If you'd like me to, I'll work them through in another video when I can write it. But right now I can't. So let me know if you need me to do that. So here's a learning check. You can sort of see what's going on here. You completed a titration. Give me 2 amphoteric substances. What makes a buffer? So it sort of goes, and we go back through everything like that. Okay, next one. Carbon dioxide's in the ocean. Why is it a concern? Because it can cause acidic things to happen in the ocean, things to kill if the buffer is overloaded. You have acid in your stomach, and the problem comes with acid in your stomach is if you have reflux. There's a little sphincter at the top of your stomach that holds the acid back. If it doesn't hold the acid back, then it comes up and burns the esophagus, and you end up with Barrett's disease, which is basically eroding of the esophagus to the point where it will fall apart. Diet does play a role in peptic ulcers. If it's too acidic or basic, then it can eat away at the ulcer. So they say there's some things that you need to avoid or things that will help you. And that's the end of that. Again, with the lab, would you please just hang on to it? I will be getting that information up to you, what you need to do. Don't forget the test on Friday. I will be putting up the password at about 10:30, well actually 9:30, at 9:30, and then it'll be open from 10 to 12, but you can only take the test for a maximum of 90 minutes during that time. Don't think you can start at noon and have 90 minutes. It has to be completed by noon. It shuts down at noon. It's really important because they really are stressing to me it can only be open a specific time, and then they're going to trash that test and put another one up for next year. So please, if you have any questions, email me, text me, message me on Canvas, whatever you can to get this done. All right, good luck. Like I said, if you need help, let me know.